tänään onkin joku eri juttu kuin mä luulin.
Mä taas olin täällä muuta, koska mä kävin täällä kysymässä mikä tää on. Mä ajattelin, että mä voinkin tulla ulos.
Joo, eikö mä olin varmaan katsonut täällä oli
Minne sä olit tulossa?
Jotain 5360.
Sehän oli ainakin joskus aikaa sitten.
Voi olla, että mä katsoin.
There's still one issue that I want to solve.
Ei!
Ei, kun minä sitä eilen katsoin ja vielä parin kertaa, että ootko mä nyt mennyt niinku sellaisena päivänä, että mä ehkä voisin tajuta siitä jotain, mutta tästä mä en kyllä ilman
No
mitään.
tästä. Mutta nyt kun tänne on tullut.
No joo.
Pieni tietokone Linuxilla.
Mikä on netti? Mitä tarkoittaa nettiä?
Mikäs tää oli? Oliko tää nyt niinku...
Ai tää tavallaan,
Mikä tää oli? Fab, mikä tää oli? Mikä tää...
Fab, mitä?
Ei kun mikä tän...
Ai tää torstai-juttu.
Niin.
Fab Academy Thursdays.
Fab Academy. No kun tää on just niinku tätä... Kun Helsinki Hack Labissa ja... Niin, Helsinki Hack Labissa. Mikä oli nyt sit niinku...
Onko se Hack Lab se mikä on siellä Pitäjänmäessä?
Joo.
Joo.
Takkatie 18.
En oo koskaan käynyt.
Fab Academy. Mikä? Sitä Orp.com.
Mä katson aina Facebook.
Yes. Yes.
Mikä tapahtuu.
All right.
Niin on.
So. Yeah. So, hello. Nice to see you.
Hello.
Welcome back.
Yeah, welcome back. Yeah, I haven't seen you for a long time. So every Thursday I'm trying to kind of come up with, not necessarily come up with new ideas, but also come up with new ideas. So trying to follow the official Fab Academy threads and topics, but also trying things on my own. So last week it was not, so there were too many technical problems with the networking in Raspberry Pi. So I couldn't find the cables and couldn't find a way how to show you the full boot process of the Raspberry Pi. But today, so I think like these problems I solved. So today we are going to talk about the Raspberry Pi, how to set up the Raspberry Pi mini computer, and maybe a little bit cover the command line. And then together we are going to install a few Python libraries in order to write some code. So to blink a few LEDs, like you see here is like a simple setup on the table with some jumper cables and the Raspberry Pi itself and an LED. And then once we will be able to successfully blink the LED or a few of those, then we are going to try to build a simple web interface or like a web endpoint, and which will allow us to control the state of the LEDs or other connected things from our computer. So we are going to connect the Raspberry Pi to a network. We are going to connect to this network with our computer also. And then we are going to send messages to the Raspberry Pi in order for it to switch some things on or off. So that's the plan.
If I share some material here from the academic program, under what item is it? Because there is no Raspberry Pi.
Raspberry Pi, yeah, there is no Raspberry Pi. So as I told, I'm also like improvising a little bit. So there's networking. So there's a week on networking, So here there's internal server error.
Networking.
Yeah, so
Okay,
if I go to
the
Fab Academy,
program is okay, this class schedule 19.
so yeah, I'll try to show you. So here's fabacademy.org. We have content. Then we have 2019. Then we go to the schedule. And as you can see, the last week was networking and communications. So I was thinking of doing something with Fusion 360 and mechanical design this time.
I wasn't so wrong because I thought that there is going to be something.
Yeah, so there was the initial plan to do a bit of mechanical design in Fusion 360, but since the last week didn't go so well, I thought of repeating it and recording a better version and yeah, getting a bit more into the ways how you can actually connect the web interfaces with the actual physical interfaces on the Raspberry Pi. So I'm repeating this, but so in the official Fab Academy curriculum, it's mostly it's a bit more complicated than the things that we are going to talk about today. In the previous weeks, so if you would join the real Fab Academy, you should have done already a few circuit boards on your own, and these circuit boards would have microcontrollers on them. And during this week, during the networking and communications week, you should be exploring ways how you can intercommunicate via microcontrollers using serial line or I2C protocols. So there are all kinds of protocols that you can use for this low level communication. But in order to get a little bit into this in a bit more lighter way, so I thought like Raspberry Pi could be a nice thing to try out, because not everybody necessarily wants to get into hardcore programming and serial communication. So I believe that this should be done in a bit more gradual way. So for those who do not have any experience, I think the starting out and understanding basic concepts of the Raspberry Pi, it might be a good way to go. So in order to start, what I would like you to do is to find a Raspberry Pi. So I'm gonna get one for you and for you, so I have a stock there. And then meanwhile I'm getting you the Raspberry Pis, you should download the operating system, which you can find under raspberrypi.org. What? But yeah, don't download the full version. Download the light version, because it's gonna download faster, and we are also going to work with the command line only today. So you go to downloads, then take a look. So click on Raspbian here, and select the Raspbian Stretch Lite. Yeah, go with the Raspbian Stretch Lite. And yeah, so download a zip. You don't have to unzip it. And the other thing that you're going to need is a tool called Echar. So which is for burning, so for copying this, for burning this operating system to an SD card. So Echar is good because it runs on all operating systems and it looks the same everywhere. So, I need to check which of those are Raspberry Pi 3s. So there's a slight difference between the Raspberry Pi versions. So Raspberry Pi 3 is the one that has Wi-Fi support, and which is what we will need today. So this is one for you.
I don't know if this will be like.
No, it just looks complicated, green and circuit boardy, but it's not necessarily the case. Usually take the one with the SD card inside already. Yeah. So this can be for you. Then you'll need a charger. So then here you go. So there's a power supply for it. We'll need also. Yeah, the only problem is that you won't. We'll need to connect it to one screen over here if we want to test it. Yeah, we have one screen, but no worries. No worries. Just I think like the important part is just to go as far as you can go, and kind of I will show you how far it goes, and then we'll be able to repeat it. So with the screen afterwards. But don't connect it yet.
Oh.
Yes.
They can SSH into the new users on the same Pi.
That's true. Yeah.
Yeah. So then they can do the things.
Yeah, at least they could emulate that. Yeah. So each of that would be an interesting thing to try. Yeah. So let's do it like so. So these Raspberry Pis are for you to kind of check more like take a look how they look, and actually, so it would be best if you would follow me how I install the Raspberry Pi from scratch, and then I will show you how you can actually connect to it via network. And we are going to add an LED for each of us, and we are going to build an interface so you could actually switch these LEDs on and off through network. So we'll have each of us will have an LED, and we're gonna try to access it. So, like in short, it goes like this. So what do you need? So now I'm gonna make this a little bit smaller. I'm gonna open Echar.
I just kind of feel like we should
Where is it?
maybe consider, like after this one, switching to the other, like just practicing.
Where is it?
Or do you think that's just too? We'll probably just have to be on that side.
Yeah, no worries. I mean, it's not necessary to boot it up. It's only for reference.
No, without memory cards, it's very hard to operate.
Why does it not? Is it on some other desktop? No. Ah, here it goes. Yeah. So to burn the image, so there are all kinds of error messages. You need to select the select image button first, and it's going to open a browser where you need to select the image that you downloaded from the website, and you open it up, and you need to select drive. So in my case, it's Not there yet. So yeah, I'm gonna insert this into my computer. So the computer should automatically detect. Not yet there. Yeah, now it's there. So for the light image, it's good to choose an SD card that is at least 4 gigabytes. But I think it's really hard to get 4 gigabytes. Like the default is 16, or sometimes you can get 8. So I usually.
Of 8, but 32 is, which I have a lot of those campus subjects.
Yeah, so now I think like I saw that now you can actually get 1 terabyte SD cards easily. So the new standards, they are becoming bigger and bigger. But on top of the capacity, what you should look into is the class. So class 10 is good. So I usually choose SanDisk Ultra class 10 cards, and they work well. You don't need really anything better. And yeah, then you hit flash.
So so I understood that I didn't succeed in bigger cards, 32 and 64.
Didn't work? Oh, that's weird. What brand were they?
Most likely Kingston.
Yeah, it's weird. Yeah, Kingstons are usually good also. So there's a page online somewhere which is kind of, there's a matrix of where users have been testing different SD cards with Raspberry Pi. Raspberry Pi SD cards. Yeah. SD cards. I think it was under elinux.org.
So you tried like a little bit of Pinout?
So here, so it's a wiki page, and there's this table here. So
What word were you using? Compatibility?
no, like look on the address. So here, elinux.org and /rp SD cards. So that's the page, and here you can see compatibility list, and it looks, yeah, that the bigger cards, they do not necessarily always work, but so I usually, Kingston's 2 and 4 gigabytes, Kingston 8 gigabyte works well. Kingston 64 gigabyte looks like somebody has tested it, it works well, even 128.
Okay, now I have it, I'll check it.
Patriot SD cards, well, and Platinum, like all these names. Samsung, yeah, a lot of SD cards. Yeah, I mean, like also the SD card reader on the Raspberry Pi, it's not the fastest. So, I mean, 20 megabytes per second, I think it's what you should usually expect, not more. Let's see what's going on with the flashing. Okay, it's still flashing. It's all right. Yeah, for the Raspberry Pi, you have also all kinds of other operating systems available. Like Noobs is selection of different operating systems. So you see you can even install Windows in it. Ubuntu.
Where could you use Windows 10 iOS 4? Okay, so is it for what is it better? Or if you have some Windows system, so why should you use it?
Maybe. I personally haven't tried, and so I have never had reason to try Windows 10.
I never had.
Yeah, maybe if you want a lightweight Windows 10 system without buying an expensive computer, so you could buy a Raspberry Pi and you could run Windows on it. But I don't really know. So maybe. So I really have no clue. So there should be, maybe it can compile Microsoft Net programs. No idea really. Then what else you could?
If you have some local Windows program which you would like to run there. So.
Maybe there's some Windows apps.
Or if they would use a Windows protocol for traffic.
So yeah, also while it is burning, then yeah, I think it's a good idea to take a look at the other available Raspberry Pi models. So we are going to use Raspberry Pi 3 Model B+. Actually, the ones that we have is just Model B. But the Raspberry Pi 3, they have a really nice feature, which is they have a Wi-Fi antenna on board and a Bluetooth antenna. So if you want to do something with Wi-Fi or Bluetooth, then it's all there. You don't need to connect any external devices. So it's not the case with the there's a Model A+. So there's a smaller version which has less USB ports, but let's see, what does the A+ offer? Does it offer Wi-Fi on board?
No.
There is a wireless LAN and Bluetooth. So yeah, so A+ is also with wireless. This is also a nice option. So I didn't know about this one. Then
there's only one USB and
yeah, but you always use a hub. So for example, if you're working more with the GPIO pins, like which are the general purpose input-output pins, it's similar as with Arduino, for example. Then you don't need like the extra USBs, and especially if you are communicating through Wi-Fi, you don't need also the Ethernet connection. So you're saving a little bit of space. Then there's also Raspberry Pi Zero, which is even smaller. So Raspberry Pi Zero W is also Wi-Fi and Bluetooth, and then there's also the same without Wi-Fi and Bluetooth. So this is an interesting option to consider. So it's really small. It comes without. I think you can get it usually with pre-soldered, with pre-soldered or not pre-soldered headers. But yeah, depends on what is your use case. And you can connect the camera here. There's one USB port for the power, and other USB port for a USB hub or things, and mini HDMI output for the screen, and of course the SD card holder. Okay, so let's see. So Echar is validating. what else? Yeah. So about the history of the Raspberry Pi, it comes. So it was invented in the UK. So there was so they made a Raspberry Pi Foundation, and the reason behind that was that there was research going on in the education structures. So the UK education was so the people involved in that were worried that less and less people who are graduating from the IT departments are actually capable of building programs or software. So they were mostly they would know some high-level things like Excel, Word, some basic IT computing, but they wouldn't necessarily be able to build software. And they started to think about the reasons behind that, and they discovered that actually it is because there are too many consumer devices nowadays all around us, and then then the kids, they start playing with these consumer devices, which are limited to buying software, buying games, and downloading movies, and so ready-made stuff. And it was not the case in the 70s and 80s. So when you would get a computer, you would really quickly run out of content, and in order to make things more interesting for yourselves, you would just start to learn programming languages, and you would try to use this computer as a creative medium. So they realized that, and they tried to look into ways how they could release a computer in the market that would be affordable to all, and they came up with this Raspberry Pi computer. I think it's also because of a really good collaboration with Broadcom, which is a microchip production company and manufacturer. Not true, yeah. And so yeah, they were collaborating, and they came up with an architecture and a board, and they started selling it, and really quickly it became popular. And so the primary goal was to use it to teach computing to kids, not necessarily programming, because it's only one side of using computers in your life. But more like they wanted to use this board to teach this whole infrastructure, or this whole network of possibilities that computing, that using a computer involves. It's not just programming. It's also a little bit of electronics. It's managing servers. It's building web services, robots, systems, and so on. And this is why you have these open GPIO pins on the Raspberry Pi, so you could play around with existing material in the real world, and you wouldn't really make your programs and make them run in closed environments, stay inside the computer, but you would actually use these programs in order to change the reality in some ways. Let's see. Yeah, so flashing is done. We can actually move to the next bit, which is
update Balena Echar. What was that?
I don't know. I think so the company behind Echar is Balena, and at some point it seems that Echar became quite popular as an application, and then everybody forgot about Balena probably, and this is why they started to brand it as Balena, although would be interesting to know. So I think I strongly encourage looking up some blog article about why is it so and not differently, but that's my assumption, that the company behind Echar, they just wanted to become more visible through the successful product of theirs, which is open source and free. Yeah. So this time I got a kind of HDMI capture device, which is going to capture my Raspberry Pi input. So I'm going to remove the SD card from the computer and insert it into the Raspberry Pi, like so. So I'm just quickly show this in the camera. Wait, like so. then yeah, so this is the setup that what I have here. So the power supply is connected, then the HDMI cable is connected, which is going to the HDMI capture device, and then a USB cable is going to the keyboard, which is here. And then yeah, the SD card is inserted, and so a good rule of thumb is that you should always connect these cables first before connecting the Raspberry Pi to the power supply. So and yeah, once you have the SD card inserted and all the periphery devices connected, then it's a good idea to connect it. And here we go. And as you see, as the first thing that the Raspberry Pi does, it's resizing the file system. It's trying to expand itself. The Raspbian file system is trying to expand itself to occupy the full the whole SD card. So in my case, it's 8 gigabytes large. So the capacity is 8 gigabytes. And it's first expanding the file system to fit that, and then it's rebooting and booting the system the first time. So which you can see now. Wonder, yeah, like so. And so always, so traditionally, from the very first days of Raspbian, it is that you're presented with this login shell, and the username is usually Pi, and the password is Raspberry. And you log in the first time. Oops. Like so. And you're presented with a command line interface like so. So you can use some basic command line tools or commands. Like for example, if you type pwd, it stands for print working directory. It's going to give you the location on the system. So // is used as a separator in the file system hierarchy. You can use CD in order to navigate it, so you can go to the root, and then you can use ls, which stands for list, in order to list. And if you type cd, which stands for change directory without any arguments, so to say, right, then you are going to be brought to the home directory again. So every user on a Unix system would have their home directory. So in this case, in the case of the Raspberry Pi and Raspbian system, it is that there's only one user, which is root user Pi. So except there's also the root user, which is a kind of a super user that you normally would use for system administration tasks. But for the sake of simplicity, in Raspbian systems, usually you would use the user Pi, and if you would need to do something as a super user, then you would use the prefix sudo, which means super user do. Yeah, first things first. So these are the basic commands. Let's go to basic configuration. What do we want to do? We want to configure the Wi-Fi.
Can you put the lights on?
Yes, that's a good idea. That's much better now. All right, so and in order to access the configuration tool, we have to type sudo config, like so, and then you enter this blue screen kind of interface, and here you can select all kinds of raspi config. So I can type you. I can show you one more time. So this is the command. So sudo raspi config. So you hit enter. You're in. And yeah, I want to connect to the Wi-Fi, which you can do in the networking options.
Another light,
Yeah, you can use this one. and then Wi-Fi. And you have to choose the region where you're from, because the radio wave regulations are different in each country. So here it goes. Here's Finland. Okay, and SSID. So we need to enter the network ID. In our case, it's Fab Lab. And the password in our case is Fabrication Lab 1. And now if I hit finish and I type hostname -i, it should give me an IP address. So this is my IP address. And now if I go back to my computer and I open the terminal. Oh, so wait a minute. Terminal application, like so. I could actually ping the Raspberry Pi by using the IP address. So 193.167.5.183. Yeah, as you see, so it responds nicely. So this is a really kind of geeky way of trying out whether something is on the network. But one other thing that we should do is to enable SSH, so which is going to allow us to connect to the Raspberry Pi via network with our own terminals and do things. So I'm going to go to sudo raspberry config once more, and I'm going to go to interfacing options and go to SSH and enable SSH. Now it's enabled. And what this is going to allow me to do, so from now on, I will be able to use the Raspberry Pi in the so-called headless mode. So I'll be able to SSH into it. So I can actually take the previous command and replace ping with SSH. Add a username in front of the IP address and an @ so it's kind of user pi at the computer that is located at this IP address. And yeah, so it's failed because I did it before and it was the same IP address. I just need to remove this key from line 87. So if you take a look at this, so then yeah, I just need to look up. So 87, that's the last key that has been added, so I have to remove this. I hit save. And I'm going to try to connect one more time. Now it's going to ask me to, if I want to continue, if the fingerprint is all right, yes. And now it's going to ask me for the password of the Raspberry Pi, which is Raspberry, and we are in. So basically now on our computer, from our computer we can control what the Raspberry Pi is doing, which is nice. So first things first, also once you install the system and once you connect to the network, it's a good idea to update the system. So sudo apt update. So update is going to update the list of available software for the Raspbian version that we just installed.
Okay, so are these updates between the main quarterly or whatever? What was the stretch was now from April 24 or what?
It should be something like that.
Up to that date,
Yeah. Yeah. So
Yeah,
I think,
Figure it out.
yeah, the deltas from that probably. So and then we use sudo because this is something that the administrator, like the super user, should do. It's too heavy for you.
Yeah, I don't choose it, but I sent an email about next week.
All right. Okay, I can hear your voice. It's not that good. Okay. Get well soon. So APT. APT upgrade. So update is just updating the lists, and upgrade is actually updating the software that we have.
APT was now.
Yeah, it used to be APT get, so they simplified things, and now it's just APT.
So, sorry, what is it?
It's advanced package tool,
package.
advanced packaging tool.
Okay, because so long, so I don't remember anymore.
So for different Linux distributions, there are different tools. So APT is for so usually APT you could find on Ubuntu and Debian systems, and then on other systems like Red Hat, usually there's Yum, I think.
Okay.
And then like sometimes so Homebrew on Mac is considered as the missing package manager for Mac. There are also Mac ports, so it makes a lot of things easier if you have a package manager that can be triggered through the command line.
If I do this at home, so do you have any list here so that I don't miss one procedure?
So not really. So this is being recorded now, so you will be able to refer to the video actually.
Okay, where do I find the video?
So on Fab Lab YouTube channel.
Fab.
I can show you.
Okay.
So if you go to YouTube and Alto. No, it's not found, but so there's something else.
Livenä nyt, yes. Tila. Okay.
Yeah, so here you go. So this is the channel, out of Fab Lab. So yeah, this is where you can find that.
Yeah, I have it here.
Good. Now, so where did I left off? So terminal.
I should find the 360 workshop. No, that's 2 hours. So where are what you have done earlier?
So these are under the playlist, the Fab Academy Thursdays, and should be there. But let's focus on the thing that we are doing today. I will show you everything later. So what we want to do, we want to actually create a Python script that would do something with the electronics through the GPIO pins. In order to do that, we are going to use a library that's called the GPIO 0. Which is a Python library that is that has been made in order to make it easier to learn programming, but also not too easy, not as easy as Scratch, for example. So it's based on Python 3, so the new Python standard. And basically we want to get this far. So we want to be able to launch this script and actually see the LED blink. And in order to get there, we first need to make sure that we have Python 3 installed. So here, let's type Python 3 -- version. And we see that Python 3 responds with its version, which is 3.5.3. And we can install this GPIO 0 library by using apt. And we do that by typing in sudo apt install Python 3 GPIO 0. So this has proven the most reliable way of installing it. Yes.
So where did you find the GPIO 0?
Here. So
Yeah, but installing. Okay, so it knows where it is.
yeah. So on Linux distributions, there's usually a configuration file which you can see. You can find under etc apt sources list. And here you can see that this is where it's looking for the sources. So for the software packages actually. So it's Raspberry and Raspberry org for stretch mainline. Yeah, and basically the package is published there, and so here in this address, the system is looking for hints where to download it from exactly.
Yeah, okay, wondering because it must be so, otherwise it would be.
Yeah, there's always a reason, why you're able to download things with the package manager. Yeah, so once we have set up the GPIO 0 library, so let's check where we are by using print working directory command. So we are in our home directory, and let's create a new directory for our test project. So I'm going to make a directory called test and change directory to it. And if I type pwd, then you'll see that I'm now in the test directory. If I list the contents of it, you'll see that there's you can see nothing. But we are going to create a new file by using the touch command, which is going to be our, let's say, blink.py. So Python scripts are usually have the extension pi. Touch is basically what is it? It's not necessarily used for creating new files, although it's a byproduct of it. But what it does refresh the creation time of the file. So it touches it, or the last used time. Yeah, the last used. So and basically when you ls the directory as a list, I think it's gonna show you this date here, and maybe if I touch it again, I think this will change. Yeah, this time, like last access time or modification time is going to change. So and now, in order to edit it, we are going to use this really simple text editor, which is called Nano, and then you just going to copy and paste this code in here just to test if things work. So blink py and So what this code does is yeah, just Control C, Control, because we are working now through SSH and with a terminal, so we can just so in your case you're using Windows, right, or you have Linux. So on the Windows case you would get a tool that's called PuTTY. And it would basically work the same way. So you would make a connection by using PuTTY, and you would end up having this terminal, and you would be able to execute all the same commands that I'm executing right now and get the same results. And here in Nano, the good thing is that we can really easily navigate the file by using our arrow keys and type something, and it's going to start typing at the place where the cursor is located. So about these first lines, so from GPIO 0 import LED, so which means that we are importing the LED part or LED class from the GPIO 0 library. And then from time import sleep, so we are importing the sleep function from the time library. Then here we are specifying which GPIO pin we are going to use for LED. And then while true means that we are entering an infinite loop. So while true is true, so it's just gonna continue on and on forever until we close the software, the script. So LED on means it's gonna provide the pin of the LED. So it's gonna switch it on. It's gonna provide 3.3 volts to it. Then it's going to sleep for 1 second, then it's going to turn it off and on. So this LED's 17.
So times are in ones and not in thousands.
You could also specify something like a floating point number. Yeah, so this is not milliseconds, so this is really seconds in Python.
That's because otherwise you don't see.
Yeah, it's in seconds. So I could also add a comment. So in. And a comment.
This is now okay. This now.
And in order to.
In Arduino, there would be milliseconds.
Yeah.
Yeah. Okay. Yeah, that's why I was one. I was wondering there. Okay. Yeah.
Then the next thing. So about this number 17. So how do you know which of the pins are is the number that you want? Luckily, there is a website which is called Pinout XYZ, where you have it all on the front page. This is the pinout of the Raspberry Pi. And what we are going to do, we are going to connect our LED to this pin number 3, which is BCM2. So also, so like
okay, sorry, yeah, now.
Pinout XYZ.
Yeah, I have it now. Yeah.
Right. So what you need to watch is that you use these BCM numbers for the GPIO 0 library, because it's going to take these BCM numbers as default values. So there are other ways how to specify the pin numbers, but BCM is the default. So if we have LED 17 in this default script, that we need to look up the BCM. So it means this pin, but we want to change it to this pin, so which is going to be BCM2. So which means that this 17 we need to change into 2. And now, in order to
BCM, where comes that from?
Broadcom, it's the chip manufacturer again.
Okay, but
Yeah.
I was what part am I missing? Of course, it's Broadcom.
Yeah, so they so it's going through this chip, and basically these are outputs of the processor that they have there, that Raspberry Pi has on board. So LED 2, yeah, and in order to save, to close and save, so there are 2 options. So write out. So you see on the bottom side of Nano, there are hints for shortcuts that you can use. So this symbol in front of the letter, it means that the control key. So if you press Control O, which means it's basically the same as save as. So Nano is going to ask you whether you want to write to the same file with the same name, and I'm just going to hit Enter for yes. And then in order to exit, I'm going to hit Control X. I'm just going to exit. Yeah, and in order to run the script, you need to use Python 3.
Shall I now contact with GPIO 3.
Yeah, so basically that would be what we should do next. So I'm going to connect the positive pin of the LED to the BCM2, so this is pin number 3, and the negative part of the pin of the LED to ground. So which is the positive? Oh, okay. Yeah. So maybe I'll switch here to the camera shortly.
Why couldn't they use the GPIO numbers directly?
So this BCM, it is the GPIO numbers as directly as you can get, actually.
Yeah, but the BCM2 is 3 and ground is 6.
I mean, in the layout, yeah. Probably there were some reasons for that.
That's only unnecessary.
I mean, I don't know. So they had their reasons. Probably the PCB layout was quite complicated.
The GPIO layout, both in Arduino and Raspberry the same.
So, no, these are two different things. Okay, now there are two completely different things. So I'm gonna run this blink program now by using Python 3 here. And so let's switch back to the camera, and as you can see, it blinks. So you can see it here.
Yeah. I couldn't see anything.
Yeah, it nicely blinks.
Okay, so and now in the blink there was the sleep one.
Yeah, and then so from here on you can try out all the other examples of the GPIO 0 library. So the basic recipes. So there are also some for driving motors, for example, that I would like to try out, but maybe not today. Where is it? Maybe advanced recipes. You can even drive them remotely. For motors, you also would need some H-bridge chips. Output devices, API. So LED, so you can see all the functions that it provides. So you can just make it to blink just like that without using the on and off commands. Fade it in and out. Drive RGB LEDs, as you see. Then buzzer, tonal buzzer. Yeah, here's like a motor. I think you need to use the H-bridge in order to control it. So which is a good thing. So there are some things that you cannot do only with.
Bridge mode. So what's that?
No, it's like a motor a chip that lets you connect external power. So let's say with the Raspberry Pi you can provide the circuit only with 3.3 volts, and it's not usually not enough for a motor.
Pi isn't providing the electricity for the motor.
Yeah, and then you need an H-bridge chip in between. Actually, so in one of the previous Fab Academy Thursdays in the videos, you can see that how we use an H-bridge in order to drive a stepper motor using an Arduino. So you could basically use the same circuit with an H-bridge in order to drive the motor by using a Raspberry Pi and the GPIO 0 library. So yeah, you can combine all that. Yeah, you see, you can drive the motor forward, the motor backward. So I think, yeah, probably also just phase. Yeah, but yeah, our goal today is actually to turn the Raspberry Pi into kind of a web server, into a simple web server, so we can send on and off commands via the browser. And this is going to look like this. So we are going to need an additional library, which is called Flask, Python Flask, and Flask. Flask. So take a look at the screen. So if you type sudo apt install python 3 flask, yes, I want to install that. And it is going to let us create really simple web server, or the so-called API. Yeah, so here we go. So yeah, now we are in the test directory on the Raspberry Pi. So print working directory gives us test. So let's go one level up. So with CD and 2 dots, we can move one level up. Move D. Let's list. And let's make another directory, which is going to be our API test. So let's make a directory that's going to be called API test. Move into it by using change directory, and let's use the touch command in order to create serve api.py script. And let's open it up by using nano. And
So you can't use nano, you must first touch it before you can open it.
no, not necessarily. You couldn't use nano straight away, but I think it's just more structured, so that you create a file, then you open it, and you could use also nano just like that.
Like I was wondering why.
So for yeah, so different people like make different habits. So my habit of doing things is this. But true, yeah. So a valid comment. So there's no right way of doing this really. And yeah, in order to start, so we need to import from Flask, a class that is called Flask, and we need to create a new Flask application, and we are just gonna assign Flask. Name is the name of the current file, and then so it has an interesting syntax. So we start out by defining the endpoint that we want to have. So something stopped there. Oh, okay. Yeah, app dot root. And so this is going to root. So when we are going to access the root of the website is gonna yeah, so this is referring to the root of the website. So when we are entering the IP address in the browser, then it's this, and then with a function definition.
Okay, by the backslash or the slash, you
I mean the root of the website.
give the IP address.
No, I will show you later how it works, but
Okay,
so this is
it
defining the root.
same.
So let's say
Okay,
we define a function for it. So it's kind of a double definition. So the top line defines that this is going to be used for whenever the user is going to access the root of the website. And just below it, we're defining the function which is going to be executed whenever the user is going to access the root of it. And we're just going to return text, which is welcome to Wonderland. And yeah, that's it. So there's another like weird line. So yeah, basically if we are running the main script.
Why are you using some places a double and here welcome only single ones?
Just because I was not careful enough.
Sorry?
Just because I was not careful enough.
Oh.
I always stick to single quotes, but there that was a double quote. That was not a habit. So I'm not the most experienced person in Python, so so this is, yeah, one should be consistent. So using single quotes or double quotes always. So single quotes is, I mean, from my experience, it is that if you're putting things in single quotes, then it's getting harder. So you're avoiding the need for interpreting the characters or some symbols in the string itself. But if you're using double quotes, then at least in PHP and also in, I think in which were the other languages that you would use? In Bash, yeah, that in double, if you use some literals in double quotes, then the interpreter is gonna interpret some parts of the text and change them into values, so change variables into values. But it's not always the case with single quotes. But in Python, I'm not really sure whether double quotes are much different from single quotes. And here, cannot really explain this one till the very detail, but here we are going to run the server. First we need to define, was it hosts? Let me see. Yeah, hosts is .0, .0, and port is 8080. So this is so if we define port as 0.0.0, that means that we are going to launch a server on all the network interfaces that are available for the Raspberry Pi, which is going to be the local network interface and also the Wi-Fi network interface, which has an IP address. And port, yeah, so normally a website uses port 80, but in order to use port 80 on the Raspberry Pi, we would need to launch the script with sudo rights. Actually, we could do just that, yes. Yeah, that's it. And now we can actually save by pressing Control W. Wait. No, Control O. Yeah, so. And Control X to exit. Let's list. So we have this serve API.py. And sudo python. So let's try without sudo. So Python 3 serve API. It's gonna give us an error because there's one. We have one quote too much. So let's fix that. So here. There's one symbol too much. And let's try to launch this Python 3 script. Yeah, you see permission denied. But if we launch the same, yeah, it's because of the port 80. But if we use sudo, it's actually going to work. And now, yeah, so let's, so this is our IP address. I'm gonna copy it. And I'm gonna launch the script again, like so. And I'm gonna move to the browser and hit this. Yeah, so can you see? You get a message, welcome to Wonderland, which means that we succeeded. So the script actually works, which is great. And you can also see that like some connection details in the console.
Because you are in different wireless network than I.
Yeah, so we should be in the same network. So the Raspberry Pi and the...
Yeah, of course, but okay, that's... Yeah, okay.
These are two computers, so you should perceive anything that is happening here in the terminal window as it would be happening on the Raspberry Pi, and then this browser is actually the computer that I'm using for streaming and for showing you things. Yeah, how about blinking LEDs? So let's open it. No, wait. Let's open it up once more in Nano. So let's define a few functions that are going to turn the LEDs on and off. So whenever we are using the path on, we want to switch the LED on or use the LED on function. And in order for that to work, we actually need to repeat a little bit from the things that we've done before. So we need to import GPI 0. So we need to import LED, like so. And yeah, along the creation of the app, we need to create an LED object. And in our case, we are going to connect it to the same GPIO pin, which is going to be the BCM2. So LED is LED 2. And yeah, let's just turn it on right away once we start. And here in the LED on, also going to use LED on. And we are going to also maybe return a message. LED should be on now. And whenever we are going to use the path off, we are going to call the LED off function. Like so, and we are going to return a message that LED should be off now. Like so, and the rest of it, we're just going to leave the same. So I'm going to use Control-O to save, yes, and Control-X to close, and I'm going to run the server as a super user, like so, and as you see the LED turned on. And now here on the screen, I'm going to switch to my camera. So we can see things going on real time. So here's the setup. And yeah, I'm gonna make this smaller, like so. And let's switch it off first. Takes some time.
Waiting, yeah. What are we waiting now? So now when you have it in
okay.
the browser,
Yeah, so that should be off. So it worked. Now on. Yeah, it's on. That should be on now. Yeah. And yeah, on top of that, we could also build a simple JavaScript, a simple interface that would be calling these two commands.
yeah, can you show me now the on-off where the code was in
Sure.
because now I just understood, because when you came from browser, that was directory also.
Yeah, so here. So this is how the code looks like.
Root. Okay, and then you backslash on the directory, so to say, because it's a root, yeah.
Yeah, so, but you can also get this. So if you go to the respective websites, so there should be a Flask documentation website somewhere. Let's try to find it.
So the Flask was Flask download file. Tutorial.
Yeah, here you go. A minimal application. So here you go. It's basically what we just did.
That was a library which was doing.
You mean the GPIO 0?
No, the Flask which you.
Yeah. So this is the library.
Imported in the Python.
Yeah. So here you go. This.
Okay, why do you have those in the name, those two before and after? Only that you see the name better, or what's the idea?
It is. Yeah, that's a good question. I think that it's creating. So here is an explanation, I think. Next, we create an instance of this class. The first argument is the name of the application's module or package. If you are using a single module, as in this example, you should use name, because depending on if it started as an application or imported as module, the name will be different, main versus the actual import name. This is needed so that Flask knows where to look for template static files and so on. It's a bit of a complicated description, but yeah, it's probably for the library to be able to kind of orient itself in the file system or so. Yeah.
One drop at a time. Great.
Yeah, one last thing that I wanted to discuss today was actually how to install this as a service. So whenever you reboot the Raspberry Pi, you would have it running automatically. So this web server, and in order to do that, you would need to create a systemd service, because like the Raspbian uses systemd.
Okay, so you mean auto-run?
Yeah, auto-run, exactly. And if we go to etc, which is the default directory on Linux systems for all kinds of configuration files, on Debian and Ubuntu systems particularly, you'll see there are a lot of configurations files for all kinds of things around the system. What we need the systemd module here.
Systemd.
It stands for system daemon. Yeah. And you see there is the system directory, and that's where all the services live. So we go to system, and here you see, yeah, all the services, reboots, yeah, DHCP. And what do we need to do here? We need to create a new service for the file. So I have also prepared a few templates for that. So what I'm going to do, I'm going to, yeah, now like another version how to create a new file. You can just call nano directly and the name of the file. So API tests dot service. Was it that we were? Oh wait, I will first check. So home pi API test. Yeah, API test. So okay, sudo nano API test.service. And here we need to, I'll just copy and paste some default code. So it's say this one. That came from a website that's called so it's devdungeon.com. So actually there's a kind of a reference. But if you use Google, you can find many references to this. So this is just another example. And you can find these in the systemd manual as well. And this is going to be REST API test description. After network target is fine, service type simple. I'm going to remove this line. User pi. Home pi. API test. And exec start. Actually, I don't need a working directory in this space. home Pi API test slash serve API EY restart on failure and install here. So I'm wondering, is it going to allow me to run it as user Pi? Actually would go with root.
Does it, if you have now the user, okay.
Yeah, like so. And so I'm gonna save this, yes, and close. Yeah, so let's try to enable it. So system ctl enable. What was the name? API test dot service. Okay, I need to authenticate as root. Raspberry. I think I pressed some buttons before. And I actually need a poll for status. So now we see that it's loaded, but it's inactive. And I can use the start and stop commands in order to start or stop it. Now it's started, and yeah, it's actually failed.
Repeat it too quickly.
That's interesting. Can I? I know what's the problem. I know what's the problem because I didn't use Python in order to run it, so I need to. Which Python 3? So I need to use this in front of the script. So nano API test, and here where there's the exact start, I need to use Python 3 in order to launch it. And now I'm going to save it and exit. Yeah. Wait a minute. I'm not as root. Not root. Yes. And now I need to, first of all, I will disable it. Then I will enable it again. Then I will try to start it. And then, okay, so it started. It actually, it turned the LED on. And status, yeah, so it's actually, it's doing something. And now we can go here and off. It's turning it off, and on, it's turning it on. And we also can try to sudo reboot. And once it boots up again, we should be there again. Here it's booting.
What was the default?
Yeah, and the LED actually turned on. So if you look here, it's the LED. And now we can also try to switch it off by calling the off function. Yes, and it works.
Mm-hmm.
Wait on. Yes, like so. So yeah, so that's it for today.
Yeah.
And then next time I'm gonna take a closer look at how to build interface with like a simple JavaScript interface by using a JavaScript framework that is called Riot.js. And we are going to use this API, or maybe a bit more complex version of this API to build an application around it. So Riot.js is something similar to the more popular and more mature brothers of it, which is React.js or Angular.js. Like React is developed by Facebook and Angular is developed by Google. But then Riot.js is yet another version. So for really small and simple applications, I think it totally makes sense. It's really lightweight. It's it's also
okay, not now.
yeah. But I'm just gonna open the website so you see what is it. So for the next time, you could if you're interested enough, then you could already check it out a little bit. So you can develop your custom tags and then use them as components in your code and make your code modular by doing so. And of course, it integrates well with other JavaScript libraries. And I think it's nice because it follows like this increasingly popular thing in terms of in the world of JavaScript, which is dependency-less libraries and applications. So the more JavaScript vanilla code, the better. And it's if you are trying to learn JavaScript in this way, then probably you're also learning more about the underlying things. So pure JavaScript. So yeah, well, for the ones watching the live stream and the recording, thank you very much that you were patient enough to get this far, and see you next week.